Hello and welcome to lesson 6 in programming microcontrollers, and in this lesson we're going to be looking at using timers rather than delays. Okay, so you can see I've got Tinkercad open. I've got wiring going from pin 2 to my first strip of NeoPixels. I've then got pin 3 going to my second strip of NeoPixels. I've got them both connected to the same ground rail, both connected to the same live rail. Then what I've got in Tinkercad is I've also got a battery pack. I'm just using 3 AA batteries. That should come in at about 4.5 volts, which should be enough to run these LEDs. However, because I'm looking at timers, what I found is Tinkercad is not great for timers. It's okay for practicing your code, but you'll not get the results you expect. So I'm actually going to get rid of this. I was only showing you so you could see the wiring close up. And what I've actually got is I'm doing this for real. So I've got the same Arduino board you may have seen in previous lessons. The wiring is the same as what you've just seen, other than I don't have a battery pack currently hooked up, which means there will be some little glitches later, but it should be enough to demonstrate this process. Okay, so I've got Arduino IDE loaded. Just make that a little bit bigger for that middle screen. Zoom in a little bit. Same as previously, I'm going to include the Adafruit libraries, or Adafruit. Because my little circular NeoPixel has about 16 pixels, in fact not about, it does have 16 pixels, I've changed the number of pixels to 16. I've got 2 strips. I'm thinking about changing these variable names from strip 1 to strip 2 to something more meaningful, but for now it'll do. So again, number 16 pixels now. You can see the square is actually 8 by 8, so therefore it's 64 pixels, but I certainly don't have the power to run 64 pixels from the 5 volts from the Arduino. It gets very unhappy. So again, I've got strip 1, strip 2, number of pixels, so I'm just staying to 16 for both. The first one's on pin 2, just like on the Tinkercad. Second one's on pin 3. So what I'm now going to do is, and this is the first part of doing the timer. Now the reason why we use timers and not delays is just for flashing LEDs, delays are absolutely fine. You can turn it on, wait a bit, turn it off, wait a bit. But if you're trying to do a control system or you want things to run at different times, then it won't work, because it'll just, while that delay is running, it's doing no other instructions. So say for example you want to have a robot detect an object, but you've got it on delay for 10 seconds. It's not going to check till that 10 seconds is up, in which case you smash into a wall. Same for if you want to play an MP3 at a certain time. While that's on delay, playing an MP3 is doing nothing else. And again, these are things that we'll cover as we go along. So current time, this is basically how long has the Arduino or ESP been turned on for, and that will give us the current time since it powered up. Now what I'm going to do is I'm going to create 3 variables, three bits of data. So this is my strip 1 data. I'm setting strip 1 interval to be 250 milliseconds. So whatever I'm going to do, I want it to happen every quarter of a second. And I'm going to have a strip 1 start. So when did this interval start actually counting? I'm also going to have a pointer. And all this pointer is going to do is point to the LED that I currently want to turn on and off. So I'm going to come down to my setup code. Inside setup, I'm going to start the strip up. So strip 1 dot begins. This tells the Arduino to start talking to the NeoPixels. I'm going to then say current time equals millis. So that again, that's basically how many milliseconds has this microcontroller been running for since we powered it up. Obviously it should be a very, very low number at this stage. And strip 1 start, so again this is my strip 1 start here. So again I'm initializing that to the same time. Now just so we can see what's happening, I'm going to also start up the serial port. So this will allow the Arduino to send data back from the Arduino itself back through the USB port, so we can view it on the serial monitor, and this helps us debug any coding issues. I'll just minimize that for the moment. So we're going to go into our main loop. Now just so we can see what's really happening, if I just say serial.print line open brackets, I'm just going to say current time semicolon. Now before I do that, I've forgotten one line of code, which is I want to get the current time each frame, each iteration of the loop, each epoch I think is the word for it. So it's going to get that time and it's going to output it. So I should already be plugged in. Yep, that's fine, I'm on COM 8. So I'm just going to send that across to the Arduino. So this is going to be NeoPixel timer tutorial. Just going to save that, compile it, and copy it across. So there we go, we can now see that it's counting up. This is obviously how many milliseconds have passed while it's running, and each time it outputs. Now the other thing to be aware of is serial.print actually takes up quite a few clock cycles, so this can slow your processor down, slow your operations down. Okay, so now we've seen that that is obviously counting up. I'm just going to get rid of that because I don't really want to use that. Like I say, it slows the computer down. What I want to do now is just sort of say, if the current time, take away the strip 1 start time, is greater than our strip 1 interval, so if the difference between start time and the now time is bigger than this 250, I want it to do something. So I'm just going to tab that in properly. I'm happy with that tab. So inside here, oops, I want it to now, I'm just going to make sure I've not deleted a bracket. No, that's fine. So basically, once more than 250 milliseconds have elapsed, I want it to trigger an event. What I'm also going to do is reset the strip 1 start time. So the first thing we'll do, we'll reset that. So that's now, at the very beginning we said strip 1 start equals millis. It's now going to set it to the current time, so it's going to keep on counting up. So we've got that time, and now I want to actually do a function. So I'm going to create like an LED chase sort of thing. So there's going to be an LED kind of going round and round. So I'm going to come outside of our loop. I'm just going to create something called void chase1. It's a function, so I do need brackets. Let's have a quick look. And because I'm being lazy, I'm just going to copy and paste from a previous project. So I've got strip 1, set pixel color to pointer 1. So that was why I created this pointer 1 variable just here. So it's going to point to the very first LED, because now we're doing timers, we can't do the loop, the for loop with the delay. So we're going to set the pixel color pointer 1, RGB, so this is going to set it to full green. We're going to then show that pixel, and then we're going to add 1 to pointer 1. So the next time it comes to this loop, it'll be on 2, 3, 4, 5, and so on, until it gets to, is pointer 1 now greater than the number of pixels? So is it now greater than this number that I set up here? Is it now greater than 16? If it is greater than 16, then I'm going to clear the pixels out. I'm going to reset pointer 1 back to 0. So if we now try run this code, let's have a quick look. Is that going to work? Yep, that should be fine. Okay, the great thing about functions is they encapsulate your code, makes it easier to read, more manageable, short these out small chunks. Biggest mistake of making functions is, yes, I've created the void my chase1 function. What I've not done is called it. So if I just say chase1, that is now going to call this function, and then it should start running. So let's try again. Okay, so there we go. We can now see it's going round just the same way as we did in the previous lesson where we did a for loop. For I equals 0, I less than 16, I plus plus, turn the LED on, wait 250 milliseconds, but now we've got it in a timer. Okay, so that's how we can handle the timers. There's now no delays. There's nothing stopping us from doing other things, outside of this function. It should run nice and quick. So to prove a point with this, if I now want to do a different pattern on a different set of LEDs, on a different NeoPixel, I can. So if I just sort of, again, I'm being lazy, I'm going to copy and paste from a previous project. It's going to come across here. So this is now my strip 2 data. Anyone who's experiencing programming, you might be now thinking we should create structures and do some object-oriented programming, and we'll get there. So now I've got strip 2 interval, but this is going to be at half second, whereas that was at a quarter of a second. I've got, again, strip 2 start, and I've now got a second pointer. So have I got the right things? I've got my strip 2. Obviously I need to begin these pixel as well. So I'm just going to go strip 2. I don't need to do current time because that's like our dominant variable. So strip 2 start equals millis. Again, I could probably get rid of that for the moment. Current time equals millis. That's fine. So now I'm going to copy and paste this. But this time, obviously I'm changing that to 2, that to 2, this also to 2, and then I want to do chase 2. But chase 2 obviously is a function that doesn't exist yet, so I need to make that. So I'm coming just after chase 1. Just move that up a little bit. So now I've got, again, strip 2.set pixel pointer 2. So what I've done with this one, if I go back up if we notice pointer 2, I'm going to start this at number of pixels, because I want this to start on the last pixel and then work backwards. So if I've got pointer 2 equals number of pixels, coming down here, setting that pixel pointer 2 to red, because obviously it's RGB, so for red, show the pixel, take away 1. So I'm going to go 16, 15, 14, etc. And then if pointer 2 goes below 0, I'm going to clear the pixels out and go back up to the starting point. So hopefully, when I press play, this should be just fine. Okay, so we can see that it's trying its best. You know, the green lights are still going round and round. The red is trying to do it, but I do know the 8x8 pixels take a lot of power, and I really should go and find a battery pack and plug it in to make it work reliably. But we can see we've now got 2 different patterns working, and if I wanted to, I could just now change the timers. So rather than every half a second, I could say let's do this every 2 seconds. Again, just quickly copy this across. Okay, so we can see that again we've got 1 LED on, 2 LEDs on. So our pattern for this one, because we're using timers, is not affecting the other pattern that we're already playing with, so we don't have to keep modifying our delay settings. So again, this is an opportunity for you to now go and play with these things, try about your own different patterns, and of course for each one you'll need to create these sets of data and just play, experiment. I'll come back to timers more as we are doing servos as well, so hopefully sometime over the next few days, next week, I'll do some more videos covering how we could maybe do a pattern on LEDs while those got separate servos moving smoothly. So again, thank you for watching. Please remember to subscribe. If you've got any suggestions for future content, please leave in the comments below, and I shall see you in the next one.